Hi, I'm Donald Sinclair. I'm a science teacher with Great London Tutors, and today we're going to be looking at a few topics in chemistry. These are how to do calculations involving potential energy. Gravitational potential energy is a measurement of how much work you have to do against the force of the weight caused by gravity. A quick review of what work done is. The work done is simply the force against which you're doing the work multiplied by the distance over which something is moved. So for example, if you were pushing a box with a resistive force of 20 newtons over a distance of 2 meters, the work done would simply be 20 times 2 equals 40 joules. A very common force, and one which we're all familiar with, is weight, which is caused by gravity. And so there are a great deal of examples where you have to work out the work done against gravity, more commonly expressed as gravitational potential energy. Consider, for example, a crane lifting a 500 kilogram mass up a height of 16 meters. If we were to use this equation here, we would have work done equals the force against which the crane is working, which in this case is the weight of the mass. So that would be the mass times the acceleration due to gravity, g, and then multiplied by the distance, which we can call a height in this case because we're moving up and down, that the crate is being moved. And this is more commonly given a different symbol. I'm going to use EP, E for energy, P for potential energy, gravitational potential energy in this case. So for this example, the mass, 500, multiplied by the acceleration due to gravity, which I'm going to use the simple value 10 here. If you want to be more precise, it's 9.81. This keeps the sums easier. Multiplied by the height over which it's moved. This gives us a total of 80,000 joules. Now this is a gain in energy. This does not mean that it had 0 joules at the start and 80,000 at the end. It simply means that after it's been raised this height, it's been given an extra 80,000 joules. If you have something falling, for example, a 50 kilogram skydiver falling out of a plane and falling a height of 1800 meters, that would be a loss of potential energy. In this case, potential energy equals the mass of the skydiver times gravity times height of 1800 meters, which would give us a total energy lost in this case of 900,000 joules. So something being raised up gains potential energy, something falling loses potential energy. Remember that G is a measure of gravitational field strength and depends on which planet you're on. You would only use 9.8 newtons per kilogram if you were on Earth. On the Moon it would be 1.6, for example, so you would weigh less. On Jupiter it would be 27, so you'd weigh more. Make sure you use the right value in your calculations. And that's how to do simple calculations involving potential energy.